Hi everyone. This is a video walkthrough of the Notional V3 upgrade. And so in this video, I'll be walking through all the commits that are scoped for the Sherlock audit starting on March 27th. Um, it's important to note that this upgrade will be happening in place on the existing Notional V2 contracts. And in many regards, the Notional, what exists on Notional V2 will continue to exist and is still part of this code base. So we'll walk through the different commits and go through what the actual changes for Notional V3 are, and I'll talk you through some of those implications. So, in my opinion, it's probably best. There's a lot of changes here. It's probably best to kind of go through the commits one by one, such that you can kind of so that it kind of tells the story of the changes that we're making. So the first commit here is a renaming of asset cache to prime cache. So this is really what the core part of what's changing in Notional V3 is that in Notional V2 we have this concept of asset cache, and to date that's really been C tokens. And C tokens earn interest on compound V2, and that interest is earned throughout all users who have deposits on Notional. Now, in Notional V3, that's going to change from C tokens to what we're calling prime cache. And prime cache is going to be the native variable rate lending and borrowing market on Notional V2. So in this first commit, really there's not much, there's really no functionality change within the code base. It's really a renaming of variables throughout. And there's a lot of files being touched here. But really, if you look at it, we're just renaming these variables to the new terminology. So in the second commit here, we have really all the updates to the mocks and the tests. So I put this in one commit such that they're off to the side and they can be reviewed if you want to. This third commit is the different updates to interfaces and other changes. So these are really non-functional changes. One thing to point out is there's some minor updates to the beacon contracts and a beacon factories added here. These are really just for convenience. So this this is not really part of the scope of the audit, but it's here as a change to the code base. This next commit is a refactor of import and using statements. So this is causing us some issues with compiling in different environments where dependencies weren't explicitly named in these Solidity files. So you can go through these files and there's really no functionality change except for changes to the imports and perhaps some addition of like new using statements and things of that nature. So we used to kind of intermix this OpenZeppelin safe math and the safe uint library. So now we're just going to use the same safe uint library throughout. So again, this commit, a lot of files touched, but no real functional changes here. This commit, which is the update to the pure math libraries. We add a pack to 32 bits function here in the floating point library. This is basically the equivalent of the pack to 56 bits function, and there's a number of additional sort of safe convert methods here. The neg change method is something that should be taken a look at. And this is what we use to get the negative change on signed values. So this is used in the prime cache code to get the amount of debt change. In this commit, we're updating constants, types, and storage slots. So again, this is something, really not like a terrible amount of functionality here. There's a number of new constants that are being defined. Um, this one is of note. So the reserve address used to be address 0 in Notional V2. However, because of the way we're going to start to emit events in order to sort of record off-chain changes to the reserve, we've split the reserve into two different addresses. This one with fee, and then this one for the settlement reserve, which is going to be used for helping us do like tracking accounting for FCAS settlement off-chain. So again, these are not functional addresses within the system. They're mainly used to kind of for off-chain tracking. And it should be noted that wherever this require valid account is used for external actions, these two addresses cannot be supplied. Other than that, there are some changes in here, but we'll sort of review them. I think they're better reviewed in the code that they're actually used. There's some changes to the deployments file. These addresses are temporary right now, so these are just for the testing environment. And as we move along, we will replace these with actual addresses. And finally, this constant is not yet set. We will set this with the timestamp of the final settlement under the Notional V2 codebase once we have a date for when Notional V3 will go live. So this is used in one place in the code, and I'll sort of point that out when we get there. The max portfolio assets is decreasing from 16 to 8. I'll go over why this is happening when we get to the removal of liquidity tokens. And lastly, so in lib storage, where you can see that some storage slots are marked as deprecated, and then a number of new storage slots are added within the library. So. Other than that, there's one sort of renaming here of a constant for clarity. But other than that, the types are defined here, and so on and so forth. So again, not a ton of functional changes here, but just some things to note. Okay, so this commit is going to be the first of where we start to actually get into the changes in Notional V3. The first big change in Notional V3 is a change to the Fcash AMM curve. So in the Notional V3 specification, which is linked in the README, the Sherlock README, there's a description of the new liquidity curve and sort of a more in-depth discussion of the design decisions in it and some of the benefits here. So I won't just kind of rehash all this stuff, but I'll give you a quick overview of what's actually happening here. So you'll see that like a lot of code in market.sol is removed, and so there's a lot of deletions in this file. Primarily the changes you'll see here are like renaming variables and like repointing functions to the interest rate curve file. So market.sol now generally is just going to have some getters and setters for the market object, and it holds this kind of like execute trade, this execute trade function. One thing to note when you look at the execute trade function, which is the primary entry point for the rest of the contracts, is the input parameters really don't change here. We're taking an additional account address, but that's mainly to ensure that events are properly emitted. So that's really not a functional change to the liquidity curve. So from the perspective of the rest of Notional, as it interacts with the new AMM, the AMM is simply going to quote different prices than the previous curve. So really, like this change should largely be isolated to what we see in this commit. The interest rate curve file here. So this is the new interest rate curve. It is defined, in this file to match the spec in the doc. Um, some some things to note about the interest rate curve. So one is the storage. So we pack the storage into one 32 byte slot. So the curve is is linear with two kinks, and it defines the interest rate, the current interest rate that Fcash trades at. So the two kinks are defined here, and there's rates defined here, and so on and so forth. So reading this will kind of give you a sense of how this is defined and how it's stored. Um, we'll get into initialized markets, but one thing I wanted to point out is that currently under the current notional liquidity curve, some aspects can be changed at any time, and other aspects can only take effect at the next quarterly roll. Under this new interest rate curve, the entire curve will only change like as governance changes the interest rate parameters, they only take effect at the next quarterly roll. So once we initialize markets every quarter, the interest rate parameters are effectively locked in for the next 3 month duration. And then governance will have the ability to update them for the following quarter. We've been running, we've been doing quarterly rolls for quite a while now, and this has not been an issue for us needing to change the interest rate curve mid-quarter. So this should work fine for us. Other than that, the rate oracle doesn't change from V2 to V3. Just moving the function here. And the rest of the calculations can be kind of seen in this file, so we won't go through them in too much detail. The calculate Fcash trade, so this it should be like largely functionally equivalent to what was in Notional V2, although some of the math is changed and simplified as a result of the simpler V3 liquidity curve. So I think the primary function where things are changing is how we record fees here. So that is something to review and ensure that this logic does indeed hold. Other than that, the calculations for the inverse are simpler, but they still use sort of a numeric approximation method. So that should be reviewed as well. To take you through some other changes here, so cash group. Cash group in Notional V2 and Notional V3 defines a number of parameters for Fcash in a given currency. Largely, those parameters aren't changing, but the ones marked as deprecated here are just no longer relevant in the new liquidity curve definition. So this should be reviewed, but not like a ton of more like removal of deprecated code here than actual additional functionality. Other than that, we can take a look at initialized markets. So in initialized markets, this is an area where we will see some effects of the new Fcash liquidity curve. So every 3 months in Notional, the Fcash positions, the Fcash markets will roll forward. It's a process that's described pretty well in the Notional V2 docs, and the process largely is not changing. Under the new Fcash curve, however, the annualized anchor rates are no longer relevant, and so we have removed them from this file. They no longer come out of governance. The end token handler doesn't record them anymore, so there's more of a deprecation of that parameter. And a lot of the math that was used under the old AMM curve is updated to what I think is a much simpler calculation here. And effectively what's happening here is that we are looking at the new interest rate curve, and we're getting the new utilization given the interest rate that the market was at the previous quarter. And then we're basically initializing the new market such that it matches the old interest rates as closely as we can. So, um, you know, the intended outputs of this change are to essentially match what happens in Notional today. Um, so mainly like everything in this commit, largely there's no sort of interface changes with the rest of the Notional V2 contracts. It's really just updating the math to ensure that our expectations continue to be met. So this is the next sort of like meaty commit in this change set. Um, in this one, what we're doing here is effectively adding the liquidity curve, the math behind the notional prime cash market. So the notional prime cash market is going to be a variable rate lending and borrowing market, very similar to what you would see on Aave or Compound or Euler. Um, so what this means effectively is that the asset rate library that we used to use as a way to convert C token denominated balances into underlying and back and forth, we're deleting that here. We're keeping a deprecated version for some backward compatibility reasons, but we're moving all of that logic into these two files, prime cash exchange rate and prime rate lib. So at a high level, the way these work is they implement the prime cash calculations that are described in this file in detail, and some of the reasoning is described here. Just kind of looking at this from top to bottom. So we have the various prime cash factors. So we have the last accrual time. So this is going to accrue as, so every time one of these prime cash balances touch, we're going to accrue interest and update the relevant variables, just like you would in any sort of DeFi variable rate money market. So we have just to kind of explain the terminology here. So we have total prime supply. This is the total lending balance. Total prime debt. This is the total debt balance. So these two numbers are going to be stored in different denominations, and that's really important to realize as you go through this code base and audit it. Total prime supply is going to be, they'll have their own exchange rates back to underlying. The Oracle supply rate here is going to refer to an oracleized version, a time-lagged version of the variable lending rate. And this is important in Notional because because in Notional it's possible to hold Fcash that's shorter dated than the 3-month market. So right after initialization, there's a 3-month market that's trading, and it's possible to trade OTC at shorter dates than that, at 1 month and maybe 2-month markets. So in order to get a interest rate to value those shorter dated Fcash assets, we need an oracleized supply rate, and that's what this is. So there's some discussion about how we calculate that. The underlying scalars and underlying value. So one unique aspect of the prime cash market is that idle assets that are sitting in Notional, say USDC, as USDC is deposited to Notional, Notional will accept USDC directly. And in Notional V2, that USDC was immediately deposited onto Compound in order to mint CUSDC and begin to earn the lending rate on Compound for USDC. In Notional V3, what we're doing is we're breaking that dependency with Compound V2. And what we're going to do is Notional V2 is going to take USDC and hold it as, strictly, unwrapped USDC tokens. And then there will be a rebalancing process where, governance can decide that maybe some of that USDC can be lent out on Aave V3, or compound V3 or some other money market to earn additional interest. So um, over time, there will be like a treasury function that mints money market USDC tokens and begins to accrue interest. So this underlying scalar and this last total underlying value are used to enable Notional to measure how much interest it's earning on these external money markets. And the supply scalar is used to measure how much prime cash holders are earning on internal notional lending and borrowing. So you can think of lenders as earning um, interest from two sources. They're earning interest from any sort of governance dictated lending activity of the underlying USDC that's held to external protocols. That is the underlying scalar. And the supply scalar is going to be interest earned from lending and borrowing activity on Notional itself, within Notional markets itself. So those two will add up to what the lenders receive. And then the debt scalar is going to be how much prime cash the debt scalar is going to dictate how much prime cash a borrower needs to repay. So, um, so one prime cash is going to be equal to some amount of underlying tokens that's potentially earning interest on an external market. So this is like better described in the specifications, and so maybe I'm getting a little tongue-tied here. Going through this, there's a lot of getters and setters in here, but the meat of the kind of important code is going to be in understanding the concepts behind updating the total prime debt and updating the total prime supply. So updating the total prime debt is going to happen whenever prime cash is borrowed or repaid. So whenever the total debt balance changes, we're going to increase the debt and supply in proportional amounts. And when the total prime supply is updated, this occurs when the total, when actual USDC, underlying tokens are added or withdrawn from the notional system. And the third thing that we track in Notional that's unique to Notional and a little different conceptually from other variable rate lending and borrowing markets is the total amount of Fcash debt outstanding. So what happens in Notional V? So what happened in Notional V2 was that when when borrowers borrowed Fcash, when that Fcash debt matured, it would mature directly into a negative cash balance, or like C tokens owed to the protocol. Now, if the borrowers did not repay on time, what Notional V2 enforced was a settlement process where cash was borrowed from the 3-month market and used to repay the debt, and then that borrower is essentially forced into another 3-month fixed rate debt. Now, this was a bit harsh for borrowers and really not a great UX, because there's this very like hard stop on that debt. And if you missed a repayment or you missed rolling that debt forward, you would sort of incur like a fairly substantial fee because you got settled. So in Notional V3, what we do is we soften this process by allowing all debts, all Fcash really, to settle into prime cash. And so in order for us to properly update the utilization of prime cash at maturity, we need to track how much debt is outstanding. So that's what this function is for. And every time Fcash balances change in the system, we need to come in here and determine whether or not the total debt outstanding has changed and update a figure for every currency in maturity. So this is really important. This is what enables us to settle all of the Fcash in the entire system at maturity without having to like loop through all the individual accounts. Below here, what we do is we start to calculate, what the interest rate accrual process looks like for prime cash. Um, the interest rate curve for that uses the same interest rate curve as we use for Fcash. So it's the same mathematics, and again, it uses the interest rate curve file. So um, the same curve dynamics will apply here as well. Um, and then, the bulk of sort of the updates to the scalars occur in here, and the logic is documented here. Um, and that's kind of it. So we expose two methods here to get the prime cache as a view function, and this one statefully, where it actually does update state. Now these return a prime rate object, and the prime rate object is used throughout the code base. Through this prime rate lib. So this exposes a number of different conversion functions where you can convert the prime rate to the stored cash balance value. So as I mentioned before, positive prime supply and negative prime debt are different denominations in storage. However, on the stack, to maintain like some like fungibility and like kind of like more or less like compatibility with the Notional V2 code base, we convert negative prime debt values into prime supply values. So what that is termed in this file is the signed prime supply value. So when we read cash balances from storage, we convert them into this like prime cash equivalent values. And so some of this math is like a little bit more described a little bit more in detail here, but that's essentially the idea here. There's also a conversion of settled Fcash. So we can take a look at that. So when Fcash is settled, we do some math here to like kind of convert it to the right, like accrue it to the right value. And again, that's discussed here. So a number of these are just kind of like conversion methods, that are used throughout the Notional code base to do the right conversions. And we'll talk about settlement in more depth, but the settlement process that I described earlier with Fcash is implemented in this file. And so you can see here, there are the kind of like updates to the total prime debt that occur when we go through settlement. We'll touch on what the settlement reserve is a little bit later when we look at events, but just to discuss it here since we're here. These are not like sort of like on-chain functional changes, like that won't have any effect on the on-chain, what's happening on-chain. But for like off-chain accounting and for clarity of like how Notional works, what we decided to do is create this sort of like settlement reserve account, which at settlement will take all of the debt that is settled at that maturity. So it represents like the global amount of Fcash debt that has settled at that point in time, and it'll emit proper events to kind of like to show that accounting. And then as individual accounts settle, they'll transfer their portion of the global debt that is settled onto their own balance sheet. So, this is really, these are kind of, I think, really nice conceptual things that we've added in Notional V3, such that off-chain monitoring systems and accounting systems don't have to like look at like Notional V2 had very like esoteric kind of like event naming scheme, but In Notional V3, we're going to basically be using like ERC20 transfers and ERC1155 transfers to represent all the different internal accounting changes. So I think it'll be a quite nice, like welcome change and make off-chain analytics a lot better. So you'll see kind of these emitter calls throughout the code base, and you know, it's an important kind of like update for us, even though it's not functional on chain. And the last thing we're adding here, you know, I'll call out here, and we'll talk about it in another commit, is a supply cap. So there will be potentially a total supply cap for a currency, and that's sort of some of the enforcement is done here. So that's a lot. This is sort of like a meaty change. This is like a lot of new logic into the notional code base. And as we go forward, we'll see it kind of get integrated into the rest of the code. So this is the first set of updates to that. You know, in this, we're updating the balance storage. So really, there's, you know, in a lot of these, you know, a lot of these functions are just renaming to match compatibility with the new methods that are in balance handlers. So, you know, again, there's like, you know, there's a lot of scattered changes to the code if you look at the pull requests as a whole. But really, like, you know, a fair number of them are just kind of like renaming and kind of maintaining like interface compatibility. In this, so the bulk of the changes here are going to be in balance handler. In this particular change, there's not like much much that's like consequential. We have a get and we add new functions for getting and setting positive cash balances. Now these will only be used for these specific like system level accounts that like are never allowed to incur debt, just as a consequence of like how the system works. So that'll be the reserve, which only like should only increase in fees, and the end token, which can only end up with positive cash balances. So setting positive cash balances is very simple. You just kind of write to storage here. Nothing nothing too novel there. In this method, in the balance handler, this is sort of like the kind of core piece of integration of Prime Cache, converting like Notional V2 to Notional V3 to use Prime Cache. So in Notional V2, we have, you know, accounts already have an existing cash balance. And so when we go from V2 to V3, what we're going to ensure in that migration process is that one Notional V2 cash balance unit is equivalent to one Notional V3 cash balance unit, and that you know, their conversion to underlying is equivalent at the point of migration. So you know, what we do there is just essentially what I kind of discussed in the last commit, which is converting these values into like the signed prime supply value, which like will start out one-to-one with like a C token, and then sort of from that point on like diverge in its exchange rate. So really the change here is that if this cash balance that we're trying to set is negative, you know, inside this convert to storage, a number of things will be triggered to convert that to the right value, and perhaps update the utilization on the prime cache curve. So you know, this is like kind of like a important bit of code, I would say, in this in this entire upgrade. Other than that, you know, not a ton that's like super interesting in here. You know, we'll take a look at free collateral, and you know, the really interesting thing about this change is, you know, we're changing, you know, we're making some updates to the code here, but it's really just to pass in this prime rate object. Free collateral as a function, as like effectively the way we value accounts, really doesn't change that much in this entire upgrade. So it's it's pretty nice that we're able to kind of like merge these concepts together. Um, but again, one of the important things about this audit and understanding this code base is that, we're changing these getters and setters. Now we're not directly changing free collateral. And our understanding is that these changes, are okay with how free collateral works. But, even if we're not changing free collateral, there might be something introduced in this change that causes it not to work properly. Um, understanding these changes is important, but it's also like, bigger part is like understanding the implications throughout the system. Okay, so this one is a much bigger change than balance handling. Token handling undergoes a lot of changes from Notional V2 to V3. And so, the big part of this is that Notional V3 no longer will accept these asset tokens, these C tokens, for newly listed currencies. So, in the bulk of these changes, um, are not going to be seen here. Um, they're going to be in this token handler file, which is, um, essentially like rewritten in this change. So um, there's a number of deposit functions. There's a withdraw function, and these are used throughout the Notional code base to transfer money into and out of Notional. So I think this is a very critical file, and does deserve like a really really close look. Again, like token handling is always an area where it's easy to make mistakes. There's a lot of gotchas and things like that. So um, I will call out one, like a couple kind of things in here. One is this execute money market redemptions. So what's going on here is that in the case that Notional decides to start lending out its underlying USDC balances to external money markets like Compound or Aave, what we'll see is that the Notional contract might be holding, $1 million in USDC, but maybe $50 million in Aave, like Aave V3 USDC. And so when someone wants to redeem $2 million, we're gonna have to go into Aave and pull, another $1 million out for that account to actually receive its USDC. So in Notional V2, that was simple because we knew all the money was on Compound and we would just go directly there. In Notional V3, since we're decoupling and we're allowing a more flexible set of money market integrations, we have a little bit more complex integration here. What we're going to do is we're going to call out to a whitelisted external contract. That's going to tell us how we should redeem from the various money markets. And it may employ, a number of different strategies, and that's something, that allows us to be flexible going into the future. But then, this function is going to go through and redeem those things and ensure that we get the right balance back. And then the second thing I wanted to call out is this stored token balance update. So really, this is to guard against the possibility of someone donating tokens, simply transferring tokens to Notional and causing that to change the money market exchange rates. This is an attack that was used against Cream, and it's something that we want to ensure that Notional is guarded against. So as deposits and withdrawals enter and leave the system, as different token balances change, we do internal counting of that rather than relying purely on calling balance of on an external contract. So you can see here we call balance of before and after different deposits and changes, and then we really just use the net balance to update our internal storage. And then the other thing to call out here is that in liquidation, liquidators would provide C tokens before. Now they'll provide the actual underlying tokens. I think that's a welcome change. Again, it'll be a lot more gas efficient for liquidators to do that. Um, so this commit is small. There's a breaking change to the end token calculation, and this is something um, which we have here. We may like flip this so that the prime cache value is supplied instead, but this is something that we'll be talking to um, some other protocols and kind of getting a sense of what they want. But this is a change to view function, and it's just kind of called out here um, separately. Um, so again, this commit, is fairly large, and I think represents another like critical change in the functionality from V2 to V3. As I discussed earlier in V3, Fcache, especially Fcache debts, will settle into this like variable rate debt, and so in order to like track that properly, we used to just track the net amount of cash that was settled. So we add the positive and negative values together. In order to track this properly, we need to split that out to see the positive and the negative values. So that's kind of being done here. Um, and the bitmap and the portfolio asset settlement is kind of like updated appropriately. Um, so bitmap doesn't really change too much. There's again we're like calling some different functions here, but like structurally it's kind of like doing the same thing as it was before. Um, Portfolio is again structurally doing what it's doing before. There are like more changes here, largely because the liquidity token is being removed from this like settle portfolio function. So we're deprecating this functionality in Notional V3. It was never really available in Notional V2 anyway. So this is really like cleaning up this file, and it's like a lot simpler to read now. And then the only account that's allowed to hold liquidity tokens is the end token account. And so, we've put settlement for liquidity tokens inside initialized markets. It's again like less if statements, a lot cleaner to read, less kind of like jumping around. So this is the entire settlement of liquidity tokens here, and you can read that. And some additional like kind of like changes to the settle end token portfolio here. So what happens now when the end tokens settle is it all happens inside initialized markets. You'll see this function and you can follow it and see what happens when the end token settles its portfolio. So again, I think these are like welcome changes from Notional V2. They like greatly simplify the logic around settlements, in my opinion. And in balance handler, we update the new cash balance. So again, we have like a prime rate lib function that does some important work for us here when when we settle. Other than that, okay. Other than that, in this change set, we also what I just described was the settlement process, like at maturity. Now, there's also changes in here that are like help like or happen prior to settlement. So what that is the calls to update total Fcash debt outstanding. So that happens in three places. That happens once when you redeem N tokens. It happens when you add new assets to a bitmap portfolio. So this is when we're setting um, uh, assets in the Fcache slots. And then it happens in the portfolio handler, specifically in the account context handler. So there is this kind of like uh, somewhat gnarly while loop here that detects changes in the portfolio and then calls the update total Fcache debt outstanding function. So it sort of like receives two sorted arrays and is looking for inserts, updates, and deletes effectively. So again, should be carefully reviewed for any sort of like logical mistakes that might exist. Um, So moving on. So this is a fairly small commit. This is what was mostly like a UX change. So we add a new flag on the account context called allow prime borrow. If the user calls this method and sets this to true, then as the account goes through batch action or withdraw or like when it hits like the balance handler, it'll be allowed to incur a negative cash balance. Now, um, this is just like a safety guard so that accounts don't accidentally like withdraw like more than their balance and start like incurring debt, so to like revert and prevent that from happening. But if an account has like an F cash debt or if it gets liquidated or something else happens, like this flag is ignored and it will incur debt no matter what. So again, that's the intended functionality, and this should be verified that that is the case. um, okay, so these next few commits, like that, the previous one and the next few are just sort of like these are updates to some of the like risk, I guess, like collateral risk in Notional V3. So this is one of those. What this adds is so effectively what this does is it changes the meaning of exchange rate buffers above 150 units. So between 100 and 150, you're going to get like a proportionate increase in the value of the debt, and then beyond that, it starts scaling up a lot faster. This basically will allow us to make it really expensive to borrow in certain currencies that we feel might be like illiquid um, and dangerous to borrow. Um, but we will like this soft cap is only enforced in like the non-leverage vault part of Notional V3. So within leverage vaults, you might be able to still borrow at really capital efficient rates. But leverage vaults are also like a different beast. So this is like uh, kind of a nice change that we made, in case we need it. Um, this change set adds the check supply cap function to various locations where the prime supply may increase, so that we can enforce a hard cap on certain currencies. Um, Again, these are not enforced on withdrawals, and it's not enforced in liquidations, and you can kind of see that. Um, okay, this change is not a huge one, but I think is a very interesting one and a very positive one for Notional. Um, so um, there's a description in here that sort of describes what's happening here, but and there's more in the specification that also describes this change. But really, what if instead of capping the amount of collateral that a liquidator can purchase to the like end token like cash balances that are available, like the liquidated account here is going to incur a variable rate debt if they get liquidated. So effectively, what this does is it transforms the risk from Notional's perspective, from the system perspective, from exchange rate risk, like the price of ETH versus USDC moving, to one of interest rate risk. So now the account, the liquidated account, is exposed to the movement in ETH interest rates rather than the movement in ETH and USDC prices. So this is going to be a really nice like risk mitigation tool for us in Notional V3. Um, Primarily, this is to guard against the possibility that um, accounts are lending ETH on Notional, and like that FETH is illiquid, like cannot be sold in the markets um, um, during liquidation. So this allows us to continue to liquidate them and remove that risk from the system. This is a I think like great change. I mean like just to simplify the code base and just make it a lot simpler. So this eliminates a lot of code um, related to the valuation and the liquidation of liquidity tokens. Again, in Notional V2, we never really allowed anyone to hold those except for the end token. And then in Notional V3, we're just kind of like formalizing the removal by like deleting all this code. Free collateral, this gets removed, and like the vast majority of this like asset handler, this valuation code is all intended to value liquidity tokens, and we're no longer allowing you to hold those. So this is a great simplification and removes a lot of code from the system. Okay, so in this commit, we're adding this new emitter library. Now, there's not really anything here that affects the affects like the on-chain execution environment like too much. Um, you know, this is really all about emitting events and emitting them in like the kind of in different situations. So there's a document in the specification here. Um, that discusses, sort of outlines the different scenarios in which events should be emitted and what types of events will be emitted. And I think it's a great doc to kind of read if you're looking for like a conceptual understanding of how Notional is like managing all this accounting between the end token and these Fcash assets and like prime cash and leverage vaults. Like what is actually happening from like a conceptual level. That's what we've tried to encode in these events and make it really easy to analyze what's happening when we look at Notional off chain. So this is something I'm really excited about because we'll be able to make some cool looking charts and graphs off of it. These next few commits, again, they're like really just like changes to add these events that I discussed into like the different places where they need to be. So in this change set, we're adding the events into the end token, like mint and redeem process. Um, so end token redeem looks like it has a lot of changes, but it was a real pain to get this like extra variable in with stack size. So um, so there are a lot of changes. There's no real intended like functional changes to end token redemption, but like code had to be moved around and like variables had to be like shifted around and things like that to get this thing to fit. So um, uh, moving on for liquidation, again, this is we're just passing an additional like account address down into these different methods so that these events can be fired properly. Here we're adding them to trading action when we lend and borrow Fcash. And then, okay, so this is a really big commit, and we're not really going to discuss it in detail. But this is a significant rewrite of the leverage vaults module. So leverage vaults is like a new module that we introduced a few months ago. And what it does is it allows these vault accounts to borrow from Notional and pursue like sort of um, whitelisted trading strategies. And so in Notional V2, leverage vaults, we call it leverage vaults V1. There's this like hard settlement process, much like Fcash debts were settled in Notional V2. And the wonderful thing about Prime Cash is that we can totally get rid of that. So in many ways, the leverage vaults are like their like behavior is a lot simpler in this V2. Um, but we've also like really like put a lot of effort into this like secondary borrow functionality, which allows a leverage vault to borrow in two currencies and pursue like leverage Uniswap V3 like LP strategies and things like that. So this is really just like a full rewrite of this module and should be treated as such. I believe it's simpler um, in this version, but again, it's a you know, it's a pretty hefty change, and so, I won't go into detail here. Um, so the next few changes are, I've labeled these as bytecode migrations. So you're going to see some changes in the code. The intention is like zero actual like functional changes. Really like we added a bunch of stuff and we started getting over the bytecode limit for Solidity contracts. So we're just like playing Tetris and trying to get all this code to fit. So in this one, we're moving this function into this library. Um, and reclaiming some bytecode here. Here removing a function between two contracts here. Um, Similarly here and similarly here. So again, everything needs to be reviewed and everything needs to be work as intended. But with these changes, didn't intend any actual like functional changes. Um, this one here, so since we're now going to start properly emitting like these uh, like ERC 1155 IDs for leveraged vaults, um, this is a bit of a refactor of the ERC 1155 contract to ensure that you're able to retrieve those balances properly. Um, there's a bit of refactoring here to kind of mesh with the Fcache IDs. The Fcache IDs are not changing from ERC 11, from Notional V2 to Notional V3. So there's a little bit of refactoring here, um, but um, but again, like intended to like maintain compatibility and maybe add a little bit new functionality here with the leverage vault IDs. So. Um, this change is just like all the changes to the governance action contract, which is really like the main entry point for like any sort of governance changes to the system. Make sure only owners on like all these functions, we'll just check real quick right now. There it is. 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 So, these are all the new like things that governance can do. Um, some things are removed. There's a couple functions that have been removed, right? So this is no longer valid. This we're deprecating since it's been unused, and this one is also unused, and this one was just particular to Aave v3. So some stuff has been removed, some stuff has been added, and so that's that. Um, All right, so this commit is about the addition of these Pcache and Pdet proxies, as well as a change to the nToken proxy. So this is really about, this is really like that interface layer to like the rest of DeFi, which is exposing like ERC20 compatible interfaces. We're also, going to get to ERC 4626 compatibility. It's not like fully implemented as of this pull request, but plans are to get there. So, these proxies are pretty thin. They're really their goal here is really to sort of like forward calls onto the I think sort of like somewhat incorrectly named contract and token action. So this also includes Pcache transfers now. Um, but really like, again, like uh, reusing like similar patterns from the end token proxy here. Um, so again, like in Notional V2, the original audit, there was a critical bug like in this transfer function that was found in the code arena audit. So even though these changes like seem pretty simple, that's usually where kind of tricky stuff gets overlooked. So don't neglect things that look simple. Um, Moving on. Just one thing to mention about this. So, like, there's 4 N tokens deployed already, 4 N token proxies deployed already. they are not upgradable. Um, so they will not be using this proxy contract. Um, so we maintain interface compatibility with them from V2 to V3. Um, but that's just something to note. It's sort of like something that already exists in the environment, I guess. In this commit, we're gonna look at money market rebalancing. So this is something we've kind of discussed already. Um, this is the rebalancing logic that sits in Treasury action. So so there's going to be a contract. So governments will be allowed to set these rebalancing targets for different currencies, and and there is a rebalance function here, which the treasury manager can call. So the treasury manager is an external contract. Um, it's uh, it's not a multi-sig. It's also a smart contract, and it's only allowed to do certain things. So there's going to be like a bot somewhere that's going to, basically call rebalance periodically. As long as whatever this cooldown is set to, it's going to call rebalance, and we're going to execute this method to move money to the right. Either take money off of money like external protocols, or put money into external protocols. So that's what's going on here. And there's you kind of take a look at the how that's executed. Um, and then there's two example like what we call like holdings oracles here. So what these do is uh, these are going to be deployed and whitelisted to tell the Notional V3 contract like how and where it's holding all of its money in a given currency, right? So with the USDC example, this is the contract that's going to say, hey, Notional, you're holding USDC underlying. You're also holding CUSDC and Compound V2. Potentially in the future, it may say, hey, you're holding like Compound V3 like USDC, and so on and so forth. And this is like the valuation of all of those holdings added together. And that's what's going to help us dictate, what the prime cash supply rate is at any point in time. Critically here, like these holding oracles, like ask Notional to give it like what Notional thinks its stored token balance is for all of its holdings, and so that's gonna, this is important to kind of mitigate that like donation type attack on Notional, and that's like a really critical thing that we want to make sure that we get down. So um, so that's what this commit is about, and as we go forward, we anticipate new money market kind of oracles being added to this library. Okay, so now we're pretty close to the end here. So this is like this one is going to be the contract that actually does the migration from Notional V2 to Notional V3. And so kind of this migration path is described here in the specification, and like this is the algorithm that we're currently anticipating using. So again, like as an auditor, I think it's good to review this and think about this, and think, hey, can this be done better or more secure? From just like algorithmically, and then and you can actually take a look at what is right now kind of like an example script, a test script of how we might actually run this run this upgrade. So again, you can take a look at this contract, and so I'll kind of walk you through what's going on in here. So what's going to happen here is we're going to call this thing that we've used a few times called the patch fix router. Now the patch fix router is a deployed contract, and it moves Notional from one version of this router contract to another. But in the middle, it's going to upgrade to itself and call like a patch fix method. So we call this atomic patch and upgrade. So prior to the transaction coming in, you're running Notional V2. You run a transaction, you come in here, a bunch of stuff happens, and then you exit the function on Notional V3. So, so here we're going to be setting the migration settings for all the different currencies. So this will set, all the prime cache stuff and so forth. We have a view function that lets us simulate this Fcache curve upgrade, and really this whole upgrade would be pretty simple, except for the fact that we have to do this this somewhat gnarly kind of swap out of the interest rate curve. So the intention here is that in Notional V2, we're going to have an interest rate curve that that's dictated by the Notional V2 interest rate AMM, and then we're going to swap that to this new AMM, right, which has a slightly different curve shape. And when we swap that interest rate curve, the main thing we want to make sure is that the interest rate doesn't change, doesn't jump all of a sudden from before and after the upgrade. So in order to do that, we have to do some kind of reverse calculation of where's the current market utilization on a given Fcache market, and how should we kind of tweak or adjust the new interest rate curve to get us to the same interest rate that we have now, so that you don't see this discrete movement in the interest rate as we go through the upgrade. So there's some math in here, is to do that, and and there's a to-do statement here, because we haven't really finalized how exactly the curve is going to be set before and after the migration. So right now this thing is going to move the interest rates 5 percentage points to or kind of move the curve 5 percentage points. Now we're going to definitely reduce this significantly before we actually run the upgrade, but we just haven't we don't have the exact numbers to do that on the current fork block. So so that concludes the change set. Again,